So, hello everyone. I'm Louise Gabion. I am in the second year of the master program Advanced Imaging and Material Appearance, also known as AIMA. And I would like to talk about centering and alignment of optical system, more precisely of the measurement of centering of optical components into optical system. But I know that most of you are quite sleepy. It's the end of the week, so I will try to do it like easily and as concise as possible. I just want your attention for the first slide, okay? And after it's okay. So let us imagine that is you freshly buy a new optical system, here a telescope, and you're very happy about it. However, you let it drop. In your misfortune, you have the luck that everything looks okay, nothing looks broken, but when you look through the system, your image is blurred at the wall image or at the edge of the image. You can even have some contrast reduction, sharpness reduction, or even some astigmatism, such as some aberrations, such as astigmatism and comas. This is probably due to the alignment of your lenses into the system that is probably broken to the fall. So some of your lenses into your system must have been shifted or tilted. And this is a problem also in common with the manufacturing process, where you can also have some surface issue where like the diopter of your lenses is shifted or tilted in comparison to the other diopter composing your lenses, or you can even have some cementing problem. Cementing is like gluing lenses together to create a new optical component. So you should probably think that to avoid, to repair this problem, you just have to shift back the lenses that have been shifted or tilted. But in fact, which lenses is shifted and tilted, and in how much, in which direction it is shifted or tilted? Because if you are doing it the wrong way, it should become even worse. This is why it's quite useful to use optical alignment measurement system. It exists many methods to do it, but I will only focus on the reflective beam method that I studied during my M1 internship. So to explain it very quickly, you have to put your system into a rotational plate, and with the aim of what is called autocollimator, we will project a vertical image, here represented by the cross, which is called the crosshair reticle, into the center of curvature of each diopter in the optical system. Then this reticle image is reflected, and we will have the information of the reticle, so the image of the reticle, into most of the time into a camera. Then we will rotationate our system, and the reticle image will have a rotational motion, and the radius of this rotational motion is linked to the centration error of our diopter. In that, we can quantify the centration error of each diopter into a system without dismantling it. This method, we need to take care of multiple aspects using this method, such as taking care of the previous diopter eccentricity, the previous diopter magnification, also that the fact that the system will measure the centration error relative to the rotational axis of the system, that is not, in most of the case, the optical axis. We also have to take care of the reticle eccentricity and a few more. Most of these problems are taken into account in most industrial measurement system we can find. But still nowadays there is some problem that is not always taken into account, such as the inner system aberration, also this sensor elimination that can be complicated when we have a lot of diopter, or even the depth of field, or DOF, or the centration, the center of curvature overlap we can have that does not allow us to distinguish diopters for the measurements. But I'm probably running out of time, so thank you for your attention, and I will be glad to respond to all of your questions.
Thank you.
Thank you for your presentation. I have a question about the process of getting the error of tilting of the centering of the elements. So on your schematic, yes,
Yeah.
this one. So we can see one lens, and with this principle, we can get the error of tip, tilt, or decentering of one lens. But can we do the same thing, but with group of like 4, 5, or 6 lenses, or do we have to get rid of each individual lenses and test them individually?
We can do it. It's the advantage of this method is that we can measure the centration error of each diopter into an optical system without dismantling it. I personally worked on a system made by Trioptics, and who allow us to measure almost in the same time the eccentricity of 20 diopters. So yeah, we can do it. The only thing that will change is the distance between the autocollimator and the upper part of our system. And we can also change what is called the focus length. So I don't know if, yeah. Okay, oh, oops, sorry. So if you can see, there is a lens at the bottom of the autocollimator. These lenses can be changed to other optical power, and to allow us to measure for most of diopter.
And do you know if we can do the same thing but with diverging groups? Because on this schematic we only have converging groups, but with diverging groups we don't have a real image. Do you know if it will work with unreal image?
It works.
Okay.
Really, it works. We can use it for different type of lenses and even diopters. Most of the time it really works well for spherical diopters. That is diverging or converging. It's not the problem. We can also use it for plane diopters and even for aspherical ones. So yeah, it's quite complex.
So you say we can use it for several lenses, but I don't understand how you can choose which lens you have to move or to correct.
Well, in fact, when you use this kind of system, you have press softwares with it, in which you will detail the optical composition of your system. Like you are saying, okay, the first diopter is a spherical diopter with this radius of curvatures and things like that. And the system and the software is here to calculate which distance he have to make between the end of the autocollimator and the first diopter. And for that, it made it able to project the reticle image into the center of curvature of your learning of the diopter you want to measure. I'm not sure if I respond to all of your questions. Yeah? Okay.
Okay. Okay. Thank you. Okay, thank you.